Hi guys, welcome to lecture 2 of our introduction to moles. So as promised, we're going to take things one step at a time, and in this lecture we are going to be working on converting between moles and mass. And remember that mass is just grams. So we're going to be using what we learned in lecture 1 to convert back and forth between that big pile of moles, that 6.02 hexillion, and mass, the thing that we can actually measure on a scale. If you haven't watched lecture 1, you have to do lecture 1 first or you're not going to understand what we're talking about today. So scooch over and do that if you haven't yet, and then come back to this one. For those of you that have done lecture 1, we're going to go ahead and start here. So starting with, just remember what we talked about last time. Balances and scales don't measure things out in moles. You can't put things on a scale to figure out a dozen, right? But that's because balances and scales measure out mass, and mass is measured in grams. So we need to be able to use our scales to figure out if we have a mole or a dozen. That's what we're going to be doing. We're going to be converting back and forth. Now, in order to convert back and forth, we have to be able to do what we learned in lecture 1, which is we have to be able to determine the molar mass using our periodic table. So you need to make sure that you can do this first. We are going to be using dimensional analysis, again, just like we did at the beginning of the year. If you had a rough time with it at the beginning of the year, please don't worry. I think it's going to be better this time because you've seen it before. And please ignore my dog who is snoring like crazy in the background. Okay, so on your paper, what you need to do first is write these two things down. These two things are our equalities. Now, we can call them equalities because they're equal to each other. 1 mole is equal to the molar mass, and it doesn't matter if you have the mole on top or the mole on bottom. It's just like flipping a domino up or down. You haven't changed the value of the domino at all, right? But these are going to be our equalities. Now, we typically call these conversion factors because we use them to convert between whatever units are on the equality. So you will hear me use the word conversion factors more so than equalities. Now, here we go. We have steps for solving problems. Now, over here to the side, I have written for you everything that you need. Up here, you'll see here are our two conversion factors. We have moles and molar mass, and those two things can go in any direction. Now, I typically don't write them on top of each other like this, honestly, just because they take up a lot of space. I write it like this off to the side. So when you're first learning, you might want to write these on your paper at the top of any paper that you're doing with problems, or maybe on an index card if you're doing them on the computer. So what I am working with here, and this is the only thing I'm working with right now, is that 1 mole of a substance equals the number of grams that we call the molar mass. And remember that we find this number by using our periodic table. So you need to have your periodic table handy and a calculator so that you can do these. So here we go. These are going to be the steps for solving every single problem that we do for the rest of the week. They're the same steps we did earlier in the year. We will write down the given information from the problem. We will bring down the units, and then we will complete the conversion with the one thing that we're allowed to do. Okay. Now, I realized as I was making my notes that there is a typo on your note sheet. So please, before you start, fix the typo on your note sheet. It should say 60 grams of NaOH. Somehow I left the H part off of your handout. So please, please fix that first so you know what's going on. Okay. All right, here we go. I am going to write down all of the steps. So step 1, write down the given. So this means that we need to write down whatever number that we were given in the problem along with the units. So this is 60 grams of NaOH. You need to include the units. This is really, really key and important. Then I'm going to draw my little boxes, okay, to keep everything organized. So I've done step 1. I wrote down the given. Step 2, I am going to bring down the units. So whatever units you just wrote down right here, they have to come down into this box, no matter what. Okay, so you can see I've put the grams on the bottom, so that was step 2. I brought down the units. And now step 3, I have to finish filling this guy out. I want to fill out the top unit and then plug in my numbers. So if I've already put grams on the bottom, that means that I'm using this one right here. Right? I've already put grams on the bottom, so that means that I must be putting the other thing on top. So I'm putting the mole on top. So I'm going to put 1 mole of NaOH up here. Now I need to look this number up. Remember that it comes from the periodic table. We're going to round it off to 2 numbers. So I looked it up and I got 40.01. Okay. So completed the conversion, check, right? Now what we can do is we can look and see if we've got what we want. If grams are here and grams are here, the units are going to cancel out. And if I stop right now, my units are going to be whatever's in that top box that's left. So it looks like my units are going to be moles of NaOH. And that's exactly what I was asked to find, moles of NaOH. So that means it's time to do the math. Now, calculator work, guys, not fancy math. This is multiplying and dividing. What we're going to do every single time is we're going to set the problem up like we just did. After we set up the problem, we multiply all the numbers on the top together, hit equals, and then we hit divided by all the numbers on the bottom. So 60 times 1 equals divided by 40.01. That will give us our answer. I get 1.4996, and then my units are what did not cancel out. They're right here, moles of NaOH. Now, the next question that people usually ask me is, well, how many numbers should I keep on my calculator on my paper? We're going to talk about that at the end of this slide show, so just hang on. We're not going to worry about it quite yet. First, we're going to work on getting these set up. Then we'll worry about how you round off your answers. So this is the first problem. All right, here's another one. And you'll notice I've got the same exact steps. I've got the same exact conversion factors over here. I'm going to do the same thing. What I would do if you're at home, this is what I'm going to do with the folks in class. I would write this down and I would hit pause and I would solve it and then come back and watch the process to see if you've done it correctly. Right? That's what I'm going to do with the people that are in class getting this lecture live. So start with the given. That was step 1. Okay. Bring down the units. So here's my units. I'm going to bring them down. Okay, done. And then step 2, fill out the top part of this. Well, if the grams are already on the bottom, that means that I'm using this one again. So the 1 mole is going to go on top. And I need a number to put on the bottom. I need that molar mass, which remember we find from the periodic table. Now I've already looked all of mine up, so I know it's 211.63. Again, I'm going to cross out the units that cancel. If I stop my answers in moles, that's what I want. So I write an equal sign and I pick up the calculator. Okay, multiply everything on the top together, divide by everything on the bottom, and I get 0.200, and these are my units right here. Moles of SrNO3 2. So if I have 42 grams of strontium nitrate, I have, what is that, about less than 1/4 of a mole. Okay, so we're going to do a few more and then you guys are going to practice them on your own. So here we have another one. This one, notice again the same steps, the same exact conversion factors. We're really doing the same process over and over again. So you want to get really comfortable with this because that's going to make life really easy for you. So write down the given. So I'm reading through my problem and this time it looks like my given is 1.5 moles of CaF2. And now they're asking me to find the grams. That's different. It doesn't matter. My steps are the same. I write down the given, which I did. I bring down the units. Well, now I'm bringing these down. So I bring them down, moles of CaF2. So now I'm using this one, right? How do I know that I'm using this one? Because I did step 2. I brought down the units and it forced me to put them in the right place, so it makes it really easy to know what to do. That means I must be putting the molar mass on top. Then I can fill in my numbers. It's 1 mole, and then I get my molar mass off the periodic table. Okay, cancel out my units. I want grams, so I'm going to stop now. I'm going to pick up my calculator, and again, same thing. Multiply across the top, divide by the bottom, and write your answer. I got 117, and these are my units, whatever's left here. Grams of CaF2. So even though it started with something different and it ended with something different, the process is exactly the same. You really need to trust the process, guys. All right, same thing like before. If you're at home, write this problem down, or it's on your note packet if you printed it out. Hit pause, then come back and see if you did it right. Okay. So hopefully you hit pause. Now we're going to go through the process here. Step 1 is write down the given. So this time it's 0.75 moles of magnesium hydroxide. So there we go, done. Step 2, bring those down, just the units, not the numbers. Okay, done. Now we go to complete the conversion. I've put the moles on the bottom, right? So that means I must put the other part of the conversion on top, because I've already committed to putting the moles on the bottom when I brought them down. I can now fill in my numbers. According to this, it's 1 mole is the molar mass, so 1. And again, I looked mine up so that you didn't have to wait on me. Okay. I want grams of magnesium hydroxide, so I'm good. I just multiply across the top and I divide by the bottom. And this time I got 44 grams of magnesium hydroxide. So we have one approach that will solve both kinds of problems, grams to moles or moles to grams. It's the same 3 steps over and over again. Now, next week, we're going to add, changing them to a different unit, but it's going to be the same exact steps again. We'll just add something to our list of options over here on the right side. Now let's go back for just a second and talk about what I said in the very first math problem, which is how do you know how many numbers to write down off of your calculator? Well, it's significant figures, guys, which we learned way back in first quarter. So I'm guessing we need a refresher, so that's what we're going to do. So just as a quick reminder, okay, sig figs are the numbers that actually carry meaning because they're related to the piece of equipment you used to measure with. Now, if you've done your 28.2 assignment, you know that the scale that was used in that lab only had 1 decimal place, right? If it only has 1 decimal place, my answer can't be something that has 10 decimal places because I didn't measure those numbers. So my answers have to reflect my measuring. And what we need to know is that our final answer that we write down can have no more significant figures than the significant figures we started with, okay? That's the big rule. Now, we learned in lecture 1 that this silly thing refuses to work, right? I cannot get this thing to work. So I will link this in Google Classroom. It will be right next to where you found this video with the Edpuzzle. Watch this video, please, by Mr. DeWitt. He explains the difference between how you would record your measurements with a plastics play scale and a NASA laser scale. It's a little bit silly, but it's really easy to understand, and it really helps you to kind of get your mind around why it matters. And if you know why it matters, you're more likely to do it and you're more likely to see the importance in doing it. So again, there's nothing here that you need to write down. I just want you to, before you go forward, hop over and watch the video about the plastic play scale versus the NASA laser scale. Then come back and finish up the rules. Did you watch the video? I hope you did. Okay, so there are going to be rules for counting sig figs. So you know from the video that what you have to do is match your answer up to the number that you started with. So in order to do that, you just have to be able to count the numbers you started with and figure out how many of them are significant based on the piece of equipment. Did you use the Barbie play scale or did you use the NASA scale? So I have a place on your paper there for you to write the rules. Okay, so rule number 1, when you're starting a problem, all of the non-zero numbers count. So you will include them in your tally. So for example, if you had the number 321 as your given, 321 grams, something like that, this number has 3 sig figs. So when you get your calculator answer, you want to round it off to have 3 sig figs, just like you started with. So that's rule number 1. Rule number 2, all zeros that are trapped between non-zeros also count. Okay, so what does that mean? That means if I have a number like 202, okay, see how this 0 is stuck between the 2's? It's trapped, it's sandwiched. That means that it's considered significant. It's important. Do you want me to give you $22 or do you want me to give you $202, right? It makes a difference. So this has also 3 significant figures. If there were multiple zeros in there, they would also count. Again, do you want $202 or do you want $2,002? Those zeros help me understand the size of that answer. So this one has a total of 4 sig figs. That's rule number 2. Rule number 3, zeros that are in the front of a number, we call those leading zeros. They don't count. They're placeholders. So that would be a number like 0.0097. These guys right here, these are leading zeros. They're keeping me from having to use a fraction. So these don't count towards our significant figure total. Only the 9 and the 7 count. So we would call this 2 sig figs. If I had 0.3, that's a leading zero, right? It doesn't really make a difference here. That would be 1 sig fig. So pretty straightforward. Leading zeros don't count. And then the last rule is the one that has a little bit of wiggle room, so you have to be careful. And that has to do with the zeros that are at the end of a number. They're called trailing zeros. Trailing zeros only count if there is a decimal somewhere in the number. Okay, so what does that mean? Well, here's an example, right? If I have the number 350 and there's no decimal here, what this really means is that my measurement is around 350. I'm not entirely sure. This has 2 significant figures. I need the last 0 so that you know it's around 350, not 35, but I'm not entirely certain about just how close to 350 it is. If I take this number and I put a decimal at the end, now I'm telling you I'm sure it's 350. I had the ability to measure this ones place, and I'm sure that it's 350 decimal. So this is 3 sig figs. And then we can add another one like this. Okay, now I'm telling you my scale could measure a decimal place. This has 1, 2, 3, 4 sig figs. So I'm even more certain about what it is. Okay, so that's kind of the tricky one. Depends on if there's a zero, or I'm sorry, a decimal. And we can put all of these rules, they all apply together. So I'm going to give you a really ugly one here. I could have a number like 0.0250030. I have managed to touch on almost every rule here. So which ones of these are significant? I just apply the rules. So the 2 and the 5 and the 3 I know count. That's rule number 1. The 2 that are sandwiched in the middle count. So I know that. That's rule number 2. Zeros in front, they do not count. That's rule number 3. And then I have to figure out what to do about this guy at the end. He's at the end of a number, so he's trailing, and it says they only count if there's a decimal somewhere in the number. Well, look at that. There is a decimal. So this guy counts. So that means I have 1, 2, 3, 4, 5, 6 sig figs in this number. So don't overthink them. They're just rules. We're going to use these rules to round off our answers. I'm going to do one example for you and kind of show you what to do if you're not sure. Okay? So while you're getting comfortable with this idea, because I know it's a little weird at first, what I suggest you do is you do regular stuff, write down your calculator answer, right, with as many numbers as you want. Then out next to it, do your best to round off to the sig figs you think it should have. So for example, here is our problem like we just learned about today. I'm going to write down my given with step 1. Okay. I'm going to bring down the units. I'm going to put the other half of the conversion up top. Look up my molar mass. Okay. So this is multiply across the top, divide by the bottom. I'm going to do regular stuff, right? I don't worry about sig figs until the very end. So I've got all kinds of numbers on my calculator. A whole bunch of numbers. That's going to be moles of Li. But this is too many numbers. The rule is it can't be any more significant figures than what I started with. So look up here. I started with this number. This is 1, 2, 3 sig figs. So my number can have, and you always count from the left, 1, 2, 3 sig figs. Then I look right here at the fourth one. I'm not going to keep it, but it's going to determine if I should round up this last number. Well, a 2 doesn't round anything up. So what I would do if I'm still getting used to this idea is I would go ahead and write this down, and then out to the side, I'm going to give it my best shot, rounding it off to the correct number of sig figs. And then this is called boxing your answer. It's good to box your final answer so you know. Notice I only look at rounding with just the very next number. I don't worry about this 7. I don't worry about this 4. Right? I just worry about what am I going to keep and look at its neighbor. And that's it. Okay. So this is our big new thing for today, converting between grams and moles. And then we are revisiting how to round our numbers off with the proper number of significant figures. So you need to head on over and do some practice problems. I'm going to have them separated out into 2 things for you. Again, they're both short, so you have easy stopping points, and that way you'll be able to easily tell kind of what's working for you and what's not working for you. So thanks for watching, and don't forget to log on early next week so that you can make a plan for next week. We're going to continue adding things to this very same process. So we want to build it up step by step. Make sure you reach out for help if you're not sure about anything, because I want you all to feel really good about this, because this is the math of chemistry.